Okay, so we're going to try to do a tutorial here for lesson 10.1 and some from 10.2 for graphing sine and cosine. Just over the basics, so hopefully this will help you. Okay, so graphing this, the main thing you need to know, or first thing you need to know, is that what a sine graph and what a cosine graph look like. So we're going to do the parent function. They all have that same basic shape. And I'm just going to make an XY table here. I know that the points I'm looking at are the quadrants on the coordinate plane. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so that whole, each quadrant there. And this would be 0, 1, 0, -1, and 0. Those are the points from the unit circle. So if we graph this on a graph, it would start at 0, 0. At pi over 2, it would go to 1. At pi, it'd be back at 0. At 3 pi over 2, we'd be at -1. And then at 2 pi, we'd be back at 0. So it looks like this, and it's the curve like up and a curve down. This is one complete cycle. Now it goes on and on forever and ever on both sides, but this is one cycle or one period. So we would say this is 2 pi, this is pi, halfway between here would be pi over 2, halfway between here would be 3 pi over 2. Cosine, on the other hand, if you think of how it is on the unit circle, we have the same quadrants, pi over 2 pi, 3 pi over 2, and 2 pi. This would be 1, 0, -1, 0, and 1. So the graph looks very similar. Oop, just hit something accidentally. The graph looks very similar to the sine graph, except it basically is like starting in a different place. So this would be 2 pi, this would be pi. So it's starting at 1, then it goes to 0, then it goes to -1, and then back to 0, and then back to 1 again. So it has that same shape. It's kind of like it just shifted over, because if it kept going, it would be down again. So we were still the up and the down from, the same thing from sine. It's just kind of shifted over, and that's what makes our cosine graph. So if we look at this as our parent function and we know this pattern, then we pretty much can do any of them that have this form. So I'm going to put y equal a sine, and I'm going to just put it all out there for you, bx minus, and you could do c or h, it really doesn't matter what letter there, plus d. This is the one that I had seen before. Okay, so it doesn't matter if it's that form or you have the cosine here. Your strategy is the same for each of these. You just got to remember what is it starting with. So for instance, what does cosine start and where does sine start? If you remember that, it will help you on all of these. Other than that, the things are pretty much all the same. So what you need to know, and I believe you guys have this down pat, the absolute value of A is called your amplitude. 2 pi divided by B is the period. And if you have this plus D out here, like this plus D, whatever that is a vertical shift. So this would be up or down. That's your dotted line, okay? That's your midline. That's easy enough to figure out. That's where your middle is. The hard part is the phase shift, okay? That's the one that gives everybody grief, and I understand. So you could essentially factor out that B and isolate it, but I'm going to show you something a little bit different. Maybe this will help. Okay, if you ever have these parentheses, whatever's in the parentheses, the bx minus c, just set that equal to 0 and solve it for x to see where you're supposed to start. So if I solve this for x, I would add c, divide by b on both sides. So that right there will tell you your starting point. Okay? Like what x you're starting with. So if we were to make a table, usually all of these values, we started 0, pi over 2, all the quadrants, right? Well, if I got a different value here other than 0, that would be this first point. Where, whatever the y was, the y will be whatever, depending on the graph, but that is a starting point. So you could essentially, do that if it helps you for that. All right, so what I'm going to do is go through an example for you, and hopefully it'll make sense. Okay, so for an example, let's look at y equal to 2 sine 4/3 x. So I'm doing a couple different ones here, so I can always do more in class if you need it. So here we know a is 2. We know our period would be 2 pi divided by 4/3. So that's 2 pi times 3/4. So that's 3 pi over 2. Okay, so on that one, that means when I do this graph, and notice I didn't add any extra because I need you to get the basic skills in first. On sine, I'm starting at 0. And then I know I go up 2, then back to 0, down 2, and back to 0. The hard part is, where is this second point? When we have this, what is that second point? So I know that if I'm starting at 0, there's no shift here. This is where it ends up, 3 pi over 2, okay? So this means this point is halfway between 0 and 3 pi over 2. So you could just count the squares and count and find the middle on your graph once you have it on there. But this ends up being, if I divide this by 2, 3 pi over 4. So the low point here and the high point here, because this is a value of 2, this would be a value of -2 here. It doesn't matter where it falls on the x-axis as long as it's in the middle, exactly in the middle between these 2 points. So it turns out that these points, this will be the third line here. So it's not actually it's not actually on a line. It's in the middle. That's okay. Just pick one. Just pick a point, midway between these two is where this top point would be. Just like midway between the others is where that point would be. So whatever that happens to be. All right, so we'll look at the next one. And you see how the graph looks like a sine graph. All right, so I'm going to go to a cosine one now. And then I'm going to do a negative just to do a negative one for you. Okay, so this one, we know a is 3. I really wish I could put -3 right here because you do have to do the negative part first. But on a test, if they ever ask you what the amplitude is, it's always the absolute value of it because it's talking about distance. All right, so our period is 2 pi divided by b, and b is 2, so our period is pi. So on this one with cosine, since we're looking at cosine, I know I'm starting at, well, because it's negative, it's at -3. So down here at -3, this is my first point. And then I know it goes up to the 0 max, which would be at 3, back to 0, and back down here to the min. Okay, so I know this is the shape because that is a cosine. So what is this value? Well, it has to be pi right here. This has to be pi, which means this max point is right in the middle, so that one would have to be at pi over 2. And then, of course, just like before, this 0 is halfway between this half, and this 0 is halfway between that half. So as long as it's halfway, you're good, whether it's on a line or not. All right, so let's look at one that's a little more complicated, one that has all that extra bells and whistles. I know that's the one you're looking for, right? Okay, so if we have y, oops, I thought I was on pencil. Okay, y equal to 3 cosine x minus 3 pi over 4 minus 1. Okay, so when I see this, the very first thing I'm noticing is that the a is 3, and the part over here means to go down 1. So that's pretty straightforward. My period, I know, is 2 pi divided by b. In this case, b is 1, so my period is 2 pi. Okay, the hard part, though, is our phase shift. That's because of this parentheses, okay, this phase shift, that piece right there. So the phase shift, because it's a negative there, that means I'm going to go right 3 pi over, oh my goodness, what did I just do? How do I get rid of that? Okay. Oh dear, I hit the wrong thing. Okay, now I'm back. Okay, 3 pi over 4. I guess I'm hitting too many things on this. I'm using explain everything, so hadn't used it in a while, so yay. Okay, so I could do that. I know my phase shift is right 3 pi over 4, or I could say if I take x minus 3 pi over 4, set it equal to 0, and solve for x, this would tell me my starting point. Okay, where do I start? I know I'm starting here. That's my x value, okay? And I'm writing kind of big because I'm running out of room here. So I kind of wanted to have all this information on the same one. See if I can do that. So if I go to graph this, I'm going down 1. Here's my midline. And let me do my midline in a different color, since I seem to sometimes forget that in class. Okay, so there's my midline. So I just took care of my down 1. Now my starting point is 3 pi over 4. So I know if you look at your graph, 3 pi over 4 should be that third line, okay? Because the way this goes, it's by quadrants, basically. So this would be pi over 4, well, not really quadrants, half a quadrants, because this would be pi over 2 on yours. This would be pi. So 3 pi over 4 is right there in the middle between 1/2 pi and pi, just like it is on your unit circle, okay? So you need to kind of get familiar with that. So 1, 2, this would be 3 pi over 2 right here. This would be 2 pi on yours, you know, if you're looking at an actual graph on the homework. So when we have this, let's see, we're starting there, and it's cosine up 3. So let me start a different color. So it's starting at 3 above this line. So I'm going, that would be 1 step, 2 step, 3 steps. So at 3 pi over 4, I'm going up 3. That's my first one. Because I would have started back here at 0, but I had to shift it right 3 pi over 4. So that's my first point. Because my period is 2 pi, that means at 2 pi, but yet it's 3 steps past 2 pi, that's my other max. Okay, that's where it starts over. Now I know exactly in the middle would be my min. So from there, let's see, how many points is that? That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4. So my min would be 3 down from there, from the middle. So 3 down from there. I'm going to just guesstimate this. Okay, 3, make that 3. Okay, so it's here. And then halfway in between each one of these is our zeros. So again, I'm going halfway here. So if I got 4, 1, 2, 3, 4, halfway would be 2 of them. So that's my 0, which is actually on that dotted line, because that's my new 0, basically. Same thing on the other side, halfway over and on the dotted line. Okay, so it's like this, like this, like this, like that. Now it does go on forever and ever, so you just keep the pattern. Count where the dots are and just count over, and you can just continue on and on and on. All right, so hopefully that helps. Okay, so now let's look at tangent right quick. I don't know how fast we can do that, but hopefully pretty fast. Okay, so on tangent, tangent looks a little bit different. Tangent has the shape kind of like a cubic graph. It kind of goes up and kind of goes down. Yours is probably much prettier than mine. And it has asymptotes, okay? It looks like this on both sides where it doesn't cross. So you need to realize, where are these? There's always the 0, 0 here in the middle. And you have an asymptote at the undefined values. So the period of these for tangent is just pi divided by b, if there's anything with it. When you're looking at this graph, I'm going to just go ahead and tell you, it's going from negative pi over 2 which is undefined, so that's your vertical asymptote, that's that dotted line. 0, you're going to have a tangent of 0, and pi over 2 is the other one. Okay, so that's always the case. The values in the middle, like a value that's here in the middle, whatever's halfway, is going to be your negative a and your a. Okay, so that's going to tell you this and this. It doesn't really ask you for amplitude on tangent, but even if you just kind of sketched it and just kept between the dotted lines, I would pretty much be happy with that. But that's what that's coming from. So when I look at, say, let's say, y equal to 2 tan x, okay, so that means when I'm going to graph this, I know I got a point 0, 0, because there's no phase shift or anything like that. I know I got a dotted line over here, a dotted line over here, and this dotted line is at pi over 2 and negative pi over 2. And I know I'm going halfway in the middle here. I'd be going up 2 on this side because it's got to go halfway in the middle down 2. So it looks like that, kind of like a cubic graph. But even if you didn't really put the 2 dot and you just kind of sketched it, that's not a problem. I'd be okay with that. If you have anything shifted over, you're basically following the same skills from the other. So what we're going to do is we'll do Delta Math tomorrow, so that way you'll have more practice with it. And then I'll have another class period to answer questions. So I hope this helps.